Alright, this is Mr. Gillum, and today we're looking at Lesson 6, Day 2 notes in your instruction book on page 54, and we're continuing to talk about dividing by a fraction. The example we're going to look at today says that Kate has 2/3 yards of fabric to make small flags. Each flag requires 1/6 of a yard of fabric. How many flags can Kate make? Read this question one more time. It says Kate has 2/3 yards of fabric to make small flags. That's how much that she actually has. She has 2/3 yards. Each flag requires 1/6 yard of fabric. That's how much one takes. How many flags can Kate make? That's what we need to figure out. Okay, how many flags can Kate make? And so it says we need to figure out how many blank are in blank. Well, I need to know, if we're figuring out how many flags she can make, how many 1/6 pieces fit into 2/3 yards. I know we need, for every 1/6 we can make a new flag, so we need to know how many 1/6 fit into 2/3. So that's what we're going to put. How many 1/6 are in 2/3? I think that S on there is for 1/6 with an S on it. That's funny. How many 1/6 are in 2/3? Now, there's actually two number lines below, but I blocked out one of them because I have the answer on it. But it says the number lines below are divided into thirds. Label 2/3 on the top number line to represent 2/3 yards of fabric. So this is a number line from 0 to 1, and it's chopped into 3 pieces. So that can be a little, you can throw some students sometimes because there's 3 dashes and there's only the number 0 and 1 on there. The reason they did that is because we made it into 3 pieces, 1, 2, and 3. This represents 1/3 of a distance from here to here. This represents 2/3 distance and 3/3 distance 1. So from here to here is 1/3, from here to here is 2/3, and from here to here is 3/3, otherwise known as a whole, or 1. So if I'm marking 2/3 on my number line, I know that it would be the second dash on the way to 1 if I divided the whole number 1 into 3 even pieces. So 2/3 goes right there. It then says that each flag requires 1/6 yard of fabric. Divide the bottom number line into sixths to show how many sixths are in 2/3. Again, we're looking at the same exact numbers on the top and bottom. So this is why the reason double number line is important is because we can see on the top and the bottom we're talking about distances. So we can tell the distance exactly. If we draw everything to scale exactly, we can compare distances. So anyway, this is 1, this is the whole number 1, and this time you can see that we separated it into 1/6 pieces. So that's 1 1/6, 2 1/6, 3, 4, 5. So there's 1, 2, 3, 4, 5, 6 1/6 pieces in a whole, which makes sense. So again, I'm gonna diagram this out for you because I want you to understand how this double number line is working here. This is 1/6 of a whole, 2/6 of a whole. We also know that it's 1/3 of a whole. 2/6 and 1/3 are actually equivalent fractions, so that's why we call it either 1/3 or 2/6. So there's 3/6 of a whole. Ooh, that would also be known as right there halfway, and you can see that that is exactly halfway between 0 and 1. 3/6 is the same as 1/2. And then we have 4/6, which is the same as 2/3. Those are equivalent fractions. 5/6 from there to there, and 6/6, also known as the whole number 1. So 1/6 goes from here to here. 2/6 is this distance. 3/6 is this distance, and so on. So we've labeled all the way to the whole number 1. However, we need to keep in mind that when we're thinking about this problem, she doesn't have a whole yard of fabric. She just has 2/3 yards of fabric. So the information I'm collecting is from 0 to 2/3 only, nothing past that, because she does not have a whole yard. She only has 2/3 of a yard. So when I divide this into sixths, I see that we have 1, 2, 3, 4, 5, 6 pieces in a whole. It says to figure out how many sixths are in 2/3. Okay, well, there's 1, 2, 3, 4. There are 4 sixths in 2/3. So if I know that there are 4 1/6 pieces in 2/3, leads me to my next answer. If I look at that means there are 4 1/6 pieces in 2/3, and there are 4 mini flags that she can make. Again, they are right here. 1, 2, 3, and 4. That's a mini flag that she can make. Every time they get this distance, that is one more mini flag. It says how many flags can she make? 4. Now let's take a look if we did it with the expression. Okay, 2/3 divided by 1/6. We talked a little bit about this yesterday, about the keep, change, flip method by using the reciprocal or flipping the fraction. The keep, change, flip method, it goes like this. Before we do 2/3 divided by 1/6, let's make some notes on the side here. And I know we wrote this down in our practice problem solving stuff, but 1 keep, 2 change, 3 flip. I know this is what you were exposed to in 5th grade. That means you keep the first fraction the same, you change the division into multiplication, and you flip the second fraction. And so you can see very clearly that there are 1, 2, 3, 4 1/6 pieces in 2/3. So I know what the answer should be. It should be 4. Let's make sure that we can get that answer. So I'm going to keep, step 1, keep 2/3. Step 2, change the division to multiplication. And step 3, flip. 1/6 becomes 6/1. When I multiply fractions, I can multiply straight across, and I get the solution of 12/3. This is a habit we need to be becoming a little more familiar with, and we'll be doing it every single time we have a fraction, especially in the context of just whole numbers. 12/3 is not a good answer for how many flags that K can make. I mean, 12/3 flags, what does that mean? Really, 12 divided by, that's what that fraction bar means, divided by 3 is actually 4. Okay, or 12/3, you could think, oh, well, 3 goes into 3 once and into 12 4 times. 4/1, or 4 divided by 1, is 4, just the way 12 divided by 3 is 4. Okay, so I know the solution would be 4. 2/3 times multiplied by 6/1, or 6, would equal 4 as well. That's the change in flip part that they've solved. So you can see that they did the keep, the change, and the flip. So 2/3 times 6 also equals 4. Keep, change, flip. Says that new problem. Kevin has 6 cups of flour. It takes 3/8 cup of flour, 3/8 of a cup of flour to make 1 cake. How many cakes can Kevin make? So again, we're trying to figure out how many cakes that he can make. And I know that for every 3/8 of a cup, he can make 1. He has 6 cups, so he can keep making cakes until he's used up 6 cups of flour. So what we need to think of is how many 3/8 will fit into 6, because he can keep making cakes until he's run out of his 6 cups. Now, this is a question that wants you to use your estimation skills. It says, do you think the number of cakes Kevin can make is greater than or less than 6? Why? And the reason they're asking this question is because sometimes students maybe forget to change and flip, or they make mistakes on the division, but they don't catch the mistakes. This is really just a chance for everybody to think about whether their answer makes sense or not. So when I think of this, I know that, okay, well, if each cake just took 1 cup of flour, I know that he could make 6 cakes because he has 6 cups of flour. So I know that he can probably make more cakes because it doesn't even take a whole cup of flour to make 1 cake. It takes less than that. So if it did take a whole cup of flour, he could make 6. It takes less than that, so he could definitely make more than 6. I think that the book actually refers to 1/2. I know that 3/8 is less than 1/2 because 4/8 would be 1/2. And I know there are 2 halves in a whole, and so he can make 12 cakes if he had half a cup of flour per cake, which is way more than 6. So I know for sure that I'm going to have more cakes when I'm all said and done. So in this case, it explains, okay, well, we're definitely going to have more than 6 cakes made because we have less than a cup of flour per cake. And so we have even less than 1. We have less than a half of a cup of flour to make 1 cake. So that's the rationale there. So that's going to help us to determine if our answer is accurate here in a second. It says represent 6 cups with 6 rectangles. 4 rectangles are shown below. Draw 2 more rectangles. So I think that on your paper there are already 4 rectangles. I'm actually going to draw my own rectangles. They're not going to be as neat as yours, hopefully, but I want to make a model from scratch so you can see where it's coming from. So the reason I'm drawing 4 rectangles is because there are, 6 rectangles, because there are 6 cups, and each of these cups is represented by a rectangle. So it says draw 2 more rectangles. I'm assuming they already put 4. I'm not sure why, but you need to have 6 total. So I'll start with that, and then what we're going to do next is we're going to actually divide these rectangles. We're going to model this by dividing these rectangles into eighths. Now, the reason I'm choosing eighths is because it says in the problem that 3/8 of a cup of flour makes 1 cake. And so if I can count how many 3/8 there are in 6 holes, then I can figure out how many cakes that they can make. So I'm dividing them into 1/8 pieces, but every 3 1/8 pieces makes 3/8. So I'm going to do this as carefully as I can here. I'm just going to draw a line straight across. There's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6 pieces, 7 pieces, 8 pieces. Okay, so I'm going to make this model just a little bit longer on these. Make my rectangles a little bit longer here. Okay, and so we can count now how many 3/8 there are in 6 holes. So I drew the line straight across all the way just to try to keep the pieces about the same size. So let's just see here. 1, 2, 3, that's 1. That's 1 3/8 cup, and that is 1 cake's worth of, I believe it's flour. Okay, so that's 1 cake that we can make. And then there's 2. That's 3/8 of a cup. There's 3. 4. 5. 6. 7, 8, and so what I'm going to do is I'm going to stop there because I'm exactly halfway done, and I see that there are 8 so far. There are 8 3/8 and 3, so I know that I have twice as many now. So instead of counting off the rest, if you would prefer to count how many more 3/8 there are, I have a feeling there's going to be 8 more. So to save time on the video here and move on a little bit, I know there's going to be 16. There's going to be 16 3/8 in 6 holes. I knew that again because I'm exactly halfway done, and I'm at exactly 8 3/8 pieces. So it says how many 3/8 cups of flour in 6 cups of flour? 16. And then 6 divided by 3/8 equals 16. And again, we could use the keep, change, flip method here. Keep the 6, change the division into multiplication, and flip the second fraction, or find the reciprocal of the second fraction. I like to think of my whole numbers as fractions as well. That leaves me with 48 thirds. 48 thirds is the same as 48 divided by 3. So if you're not sure what 48 divided by 3 is, or if 3 goes into 48, we can find out. Bring down the 8. Looks like to me we get 16. So we get 16 using either method. And so looks like these might have to go on to a second day of videos. So I'm going to pause this and we're going to continue on. On second thought, let's do this one in class. Just remind me.